Afternoon, grade fives, and welcome back to one of my videos. I'm hoping that this time it's a little bit better and that you guys will enjoy it just as much as you did last time. As we get more into science, we're going to have to find and investigate different situations, which makes science really exciting. And if we're going to become scientists one day, we're going to have more advanced and complicated investigations as we get further in. So it's quite exciting to know that there are 7 scientific investigation steps, and you guys have been given this on the D6 and on Seesaw, so you should by now know exactly what I'm talking about. And as I said above, the flow diagram flows from the one side and you follow the arrows as you go along. All right. Obviously, each section is a little bit advanced and complicated and gives you as much information as I can in those different steps. But there are key words in every single block. So if you learn those key words, as you can see on the second page that I gave you, the first key word is identify the topic. And then over here, it's got more detailed information. Identify the topic or thing you're going to observe or what your topic is going to be about. All right. Number 2 says ask yourself questions. And then this is a little bit more advanced, giving you examples. When you have to study this for exam purposes, as long as you understand what each of these areas is explaining, then you're just going to need to have these basic keywords in your mind. And if you can remember the investigation that we're doing today and the investigations that we'll do throughout the rest of the year, it's going to be easy for you to remember these 7 basic steps. All right. So what we're going to do today is we are going to investigate the different properties and how metals and non-metals can conduct heat. All right. Sorry, let me get it like this. We're going to, first of all, it says at the top, to identify a topic or thing, describe your observations or what your topic is about. So now we've decided that we're going to investigate how well materials conduct heat. That is the first topic. That is what we're going to be doing. The next step in our 7 processes over here, in the 7 scientific investigation steps, the second step we see is asking questions. I don't want to jump around too much. So here we go. Which materials conduct heat better is the next question we're going to ask ourselves. Are they metals or are they non-metals? And number 3 is the prediction process, the prediction step. This is also called a hypothesis. Well, it's quite a big word for you guys to remember, but all it means is your prediction. And as in maths, when you're asked to predict something, it's a guess. It's an educated guess. A prediction is not something where you say the answer is exactly this. It's what you think based on what you've already experienced in the past. So the next step we're going to do is to plan our investigation. There is the planning of the investigation, and this is quite a long process. As you can see, it takes up the entire page. Planning of the investigation, firstly, we need to list the materials and equipment you will use. Write down step by step the method. So the equipment and materials that we're going to use to see whether the product is conductive and conducts heat well or doesn't conduct heat well. At this stage, my prediction, sorry to go back to step number 3, I predicted that non-metals conduct heat the best. So just trying to see what the outcome of this test and investigation is going to be. In step number 4, as we go back to that page that I was on earlier, we need to list the equipment that we need to use. So if you can see here, I have a candle, a lighter, I have 3 spoons, all made of different materials. Right? This is a wooden spoon, which is a non-metal, and this is a plastic spoon, which is another non-metal. This is a metal spoon, so it's steel and it's metal. All right. We need to see now which of these will conduct heat the best. We also need to have a stopwatch in place, and I'll explain that to you just now. When we start to measure the temperature of, not the temperature, but which of these spoons melt the butter first. So that's all the equipment that we need for this investigation. All right. Now, the next step, I will light the candle and make sure that the flame is nice and high. I don't want my flame to be small for the one step and big for the other spoon. It must be about the same height for all the spoons. Let me just read on to give you an idea of what the steps are. I'll then place the same amount of butter into each teaspoon. I will have a timer ready, and I'll hold my first spoon about 5 centimeters above the flame and keep track of the time using my stopwatch on my cell phone. I'll then record this time and move on to the second spoon. Once all the butter has melted, I'll just record the time that it took for that butter to melt on that specific spoon. Then finally, I will test this third spoon and record the results according to the amount of time it took for the butter to melt on that specific spoon. So there we go. What we must remember is that there are variables that are in place, and controlled variables environment. Some are different temperatures, and if I've got a window on the one side and the window's allowing too much air to come in and blow my flame around, and then all of a sudden there's no wind coming in, or I just quickly close the door, it's going to be a little bit of a problem because my one spoon is going to get more heat than the other spoon. Another variable is the amount of butter that I put onto the spoon. Obviously, if I put a whole wad of butter on the one spoon, it'll take much longer for that spoon to melt than it would, that butter to melt than it would on the spoon that's just got a little bit of butter. So the butter has to be almost the same amount. The distance from the flame. Now, what happens if I hold my spoon this high for one experiment, and for the very next experiment, I hold my spoon this high? Obviously, it would take longer for the heat to reach the spoon if it's higher up. So my control variable there means that I actually have to control the distance of each spoon from the flame. So it's air movement, it's distance from the flame, it's amount of butter, and it's the flame height. Then we have what we call independent variables, and this independent variable is going to be the variable that changes. And the variable that changes here are the spoons, or actually the materials of the spoons. I tried to keep all the spoons the same thickness. Let's get the candle flame going just to get it ready for when we're ready. Okay, remember, I don't want you guys playing with fire at home. We're not allowed to play with flames by ourselves, or with lighters or matches, okay? I don't want you burning down the house during lockdown, all right? So you're welcome to do this around your parents, but make sure that you don't burn the house down. So here we go. I take the same amount of butter. I try and do just a little bit because I don't want it to take hours and hours. See there? It's only a little bit, and I put it in the center of the steel spoon, metal spoon. I take this lovely little wooden spoon. That looks like a little bit more. Let's not go overboard. This is G. Okay, we take that, and once again, we want to place it in the center of the wooden spoon. Here we are. We're just getting everything ready for our investigation, which is super exciting, if you're going to be a scientist one day. All right, and then we put this one in the middle again. All right. I've tried to be fair as I can to make them the same. Right. Now what we're going to do is we're going to, first, I'm going to switch on the stopwatch. Here's my stopwatch. And then I'm going to put the steel spoon over the candle. Just remember that I don't want to waste your time, so we're going to pause it, and then I'm going to start it again, and you can see how long it took for the butter to melt on the metal spoon. Right, so here we go. Wait a bit, please. I'm keeping it the right distance, the same distance as I will keep. As you can see, I'm just going to take it off the flame. How quickly did that butter melt? How quickly exactly? 19 seconds. Well, there we go. That's quite impressive. Right, so we've got that. Now what I'm going to do is, before I forget the amount of time, I just want to write it in over here. Metal spoon, is it time it takes to melt the butter? Whoa, this one's running out of ink. 19 seconds. Okay. Right, now we're going to do the same with the plastic spoon. All right, and we're going to hold it the same distance away as we did the wooden one. All right, I need to clear this. Stop. Push play and same distance from the flame as the metal spoon. Whoopsie, that was a little bit low. See, I've got to keep it the same distance, okay? Right, I just wanted to show you that it took us 32 seconds. You need to trust me on this one because I didn't want to waste your time. But it took 32 seconds to melt this butter on the plastic spoon. Right, now we're going to go to the wooden spoon. Why don't we just leave it on for this one to show them? Okay, let's leave it on for this one the whole way through. I just need to clear this, and I keep forgetting how to clear it. So I'll just push stopwatch again. That's not working for me. There we go, we're right back to 0. And we're going to leave it on just to confirm with you how long this wooden one takes. All right, let's go. I'm going to push start, and I'm going to put my wooden spoon about the same temperature above the flame. Let's see how long this wooden one takes to melt. Well, as you can see, the flame is moving a bit, which is a bit, there's obviously an airflow that's coming in here. So I'm actually just going to hold my hand like this to try and prevent the heat, the flame from bouncing around. Right, it's starting to melt. What's it on at the moment? 39 seconds. Yo. Okay, it still hasn't melted fully, and it's sitting on 47 seconds. Okay, I can still see a couple of blobs in there. Maybe I should shake it around. No, that's not a good idea. And it's done. Okay, there it is. And that was 59 seconds. And let's just write that down. No, that was the wooden spoon, and it was 59 seconds. So I made a little mistake. Oh, goodness me. I forgot to record the plastic spoon, but I do remember that it was somewhere between 32 and 35. So I'm just going to write here 32 to 35 seconds. Okay. That's not very accurate and scientific of me, is it? But I don't want to have to go all the way back and start this entire video again. So this is all my fault. Okay, so let's have a look here. That's just showing you that you guys have to record things accurately. All right. Which of these would you say conducts heat the best? Okay, I would say the metal spoon, because the butter melted much quicker on the metal spoon than it melted on the wooden spoon or the plastic spoon. So the best result was with the metal spoon, and I'm going to put good. Which one was the next best conductor of heat? And it's the plastic spoon. So I'm going to put fair, which means it's kind of average, okay? And the worst conductor of heat would have been the wooden spoon. So I'm going to put bad. All right, so if you have a look here, that's what our little table is telling us, that the metal spoon is by far the best. If you have a look over here, it says, was your prediction correct? My prediction was incorrect, because I thought the butter in the plastic spoon would melt the quickest, and that the plastic was the best conductor of heat. The investigation proves that the metal spoon is the best conductor of heat. All right, so that was step 6 of our 7 steps, and our seventh step says evaluate. Look at what you have done and think how to do it better. Right? Next time. I know I made a little mistake in that I forgot over here to write that down immediately. So I knew it was 32, 35, but there's my mistake. We make silly mistakes all the time, and I should have recorded it immediately. So that's something that you guys can improve on, and make sure you record it immediately, otherwise you forget if you're old like me. All right? Identify problems and try to think of ways to solve them and improve your investigation. Communicate all your findings in an oral presentation, poster, or report. So I just want to explain one other problem that I had. Even though I said to you that we must make sure our windows and doors are all closed, I forgot about the one behind me. All right, there's a sliding door behind me. All the other windows are closed, the doors are closed around me, except through there's a sliding door that's open. And that was very naughty of me. So the problem there is that this flame every now and then moved around a little bit. Okay? depending on the wind that came through that back door. I thought it was far enough not to consider it, but clearly I was wrong. All right, so thanks once again for watching my video, and I hope that you really, really enjoyed it. If you want to, I need you guys to consider doing another little investigation of your own. So you need to boil a kettle. Remember again, that hot water is very dangerous. I don't want you burning yourselves, so ask your mom to help you if she doesn't want you going near the kettle. You're going to need 3 different types of materials, all about the same thickness. It does make a big difference, and we're also going to test the conductivity of these 3 materials. Once again, I've got a metal, I've got a wooden stick, this is a metal straw, very good for the environment. This is a chopstick of some sort, not quite sure what this is, and this is a knitting needle. So I'm going to boil the kettle. Here's the kettle, and we're going to do an investigation very similar at home to what we've done here, using these products and a bowl of boiling water. Remember, it's steaming, piping hot. So here we go, and I'm going to place these. Are you all steamed up there? I'm going to place these 3 rods, if we can call that. But firstly, I'm just going to get my timer correct. All right. They're all going into the same temperature. And when I take them out, in 30 seconds, I can touch them. In a minute, I can touch them. And I can see exactly which one is the hottest. So let's go onto stopwatch, timer actually. And I'm going to put all 3 of them in, and I'm going to push go. All right. Well, this wooden one wants to float. Okay, I can always hold them down. Let's hold them down just for the purpose of this test. Okay, so I'm timing at the moment. We're on 10 seconds at the moment, and we're following on 15 seconds. I think after 30 seconds, we're going to know which is the hottest material, which material conducts the heat the best. But you know what, kids? I don't want to do this test for you. I need you guys to do this investigation by yourselves. So I'm going to stop my watch right now, and I'm not going to tell you which one is the hottest. I'm going to let you do the investigation for yourselves, because science is fun. Okay, until we see each other again soon, be good and look after yourselves. Bye.